right, so we are going to have a quiz tomorrow on sections 9.1 through 9.4 in your textbook. This is all about circles. It starts with section 9.1, which are the circle basics of naming parts, major and minor arcs, central angles being congruent to the intercepted arc degree measure versus arc length, chords and arcs theorem. All of those things are going to be a part of your quiz tomorrow. Also section 9.2 dealing with radius, chords, and tangents. And then 9.3 and 9.4 as well with the new angle relationships that we've talked about, inscribed angles and angles inside and outside of circles. So what is it that you should study? You should study your notes. You should have lots of these from this unit. I gave you a graphic organizer. We filled this in last week together. We also had an exit card. These concepts are also going to be on your quiz tomorrow. You had sections from your textbook homework that you want to look at, as well as class assignments. And this is the one of the ones that we did starting in class together on Friday. So any of these items on circles are going to be helpful for you to study. I'm going to run through an overview of just some of the basics, mainly focused on the graphic organizer because that's the newer stuff. I am not going to do too much in this video with the naming of parts, major, minor arcs, arc degree, length, and arc measure. I'm mainly going to focus on the relationships from our capture sheet graphic organizer for angle arc relationships. Okay? So let's get started. First off, when you're solving for a circle, you need to check for all of those things that we just talked about. So you need to check and see, are there central angles? Are there inscribed angles? Are there any triangles? If so, are they isosceles or equilateral? Are there vertical angles? Is there a linear pair or supplementary angles in the circle? Do I have any 90-degree angles that form right triangles? Does a chord bisect a radii? Is a radii intersect a tangent at a point of tangency? Is there a diameter where the arc is 180 degrees? Is there anything that I'm going to have to use that goes 360 degrees around a circle? You should know all radii of the same circle are congruent. Is the vertex inside the circle, which is half the sum, or is the vertex outside the circle, which is half the difference? Okay, so all of these things are things you have to check for, and that's what can make circles complicated, is that when you're given a circle, it doesn't automatically jump out to you all the time which it is. You have to think critically and be able to determine which relationship it is. Okay? Alright, so let's get to some sample problems. First off, we are going to take a look at some just chord relationships. We did do these in class today, so this is just going to be kind of a review for those of you who may have missed something that I said or something that I did. If you need to replay any parts of this video, then you can do that as well. Okay? So a lot of these I'm not going to go through and fully solve and explain to the fullest extent again, but what I'm drawing right now are radii. And I know that radii of the same circle are always congruent. So I do know that these are isosceles triangles and that the altitudes of these isosceles triangles are 8. So if I have two isosceles triangles and their altitudes are the same, I know that the triangles are congruent. Therefore, I am given an expression for AB and I am given an expression for CD. So what I'm going to do is I know that this segment is congruent to this segment because the two triangles are the same. So essentially all I'm going to do is set those two expressions equal to each other that I'm given, and then solve them. Okay? So there's my equation. I am then going to solve for x, and I get x is 9. Now that's not where I want to stop because they actually want me to actually go further and find PA, which the segment I'm actually looking for is PA right here, which if you notice is the hypotenuse of this right triangle. The question is, how do I get this bottom part of the triangle? Well, I know that AB has an expression of 2x plus 7. And I know x, so if I plug it in, I know that the entire segment length is 25. Now that gives me this entire segment length. Since this is perpendicular, this is technically a radius, is perpendicular to this chord, I know that it bisects this chord. So if I know the whole thing is 25, that means I know the base of that triangle right there, which I'm going to pull out, is actually 12.5. They give me 8, so now I'm just looking for C, which is the Pythagorean theorem. So I'm going to say 8 squared plus, that's 12.5. 12.5 squared equals C squared. and then I'm going to solve this. So I'm going to take the square roots of both sides, and I get C is about 14.841, and that is in units. Okay, because I'm solving for the length. This is based on the same concept, however, it's a little bit more simplistic because I know that this segment and this segment are congruent, and I know again that my radius form congruent triangles, so therefore I can say that my altitudes here that are given to me, because I know these are perpendicular, are equal. So I just say again x plus 6 equals 2x minus 1, and I solve. And I get that x is 7. And now if I want to find PA, I just plug it back into that expression to actually solve for PA. So 2 times 7 minus 1, 14 minus 1, which is 13. Okay? So this is just your chord relationships with something being perpendicular to another piece. You might have to use Pythagorean theorem. You might have to set up an equation and solve it before you can actually plug in the piece that you need. But you should be aware of these relationships. The next thing we're going to look at is central angles. So whenever you have the vertex on the center of the circle, central angles are equal or congruent to the intercepted arc. So here's my vertex. Notice it's the vertex of this angle and it's the vertex of this angle. So therefore, since they are vertices, the vertices of both of those angles is on the center. I also know that these two angles are congruent because they're vertical angles, which means that this arc is congruent to this arc. And again, all I do is set the expressions equal, and I solve them for x. So I subtract 2x, I get x plus 5 equals 12, subtract 5, and x equals 7. And in this problem, that's all they wanted me to find. They wanted me to find what x was, and I found x. They could ask me to go ahead and now find the arc degree measures, and then also to identify what the central angle is, because I know that those are actually equal. Down here, I'm looking for the measure of arc RTV. So I'm looking for arc R going around to T, going around to V. So I'm looking for that whole arc measure. So what would be the degrees that I just am sketching around this circle? Well, if this is 110, I see that these two arcs, this arc and this arc, both form 180 degrees. So if this is 110, I'm left over with 70. Now I'm only missing this angle here. Well, if you also notice, I have vertical angles. Okay, so let me clear this off just so that it makes it a little bit easier to see. Okay, so I have that this angle, this diameter, and this diameter. So I know that this angle is congruent to this angle. So if both of these angles are equal, this one's 110, that means this is 110, and I just subtract 110 minus 58 to find that other piece right here. So when I do that, I get 52 degrees. So if this is 52 degrees, now I want to go back and I want to actually add together everything. So I'm looking for arc R, T, V. So I'm going to take my 110, my 70, and my 52. I also know that this is 70 because they're vertical angles, and I'm going to add all these together. And when I do that, 70 plus 58 plus 52 plus 70, nope, that's right. I should get 250. Let's see, 7 and 7 is 14, 15, yeah, 250. Okay, so I get 250 degrees. Now, you could do it that way, or there's a much easier way to do this, because if I'm looking for everything except for the 110, I could also just take 360 and subtract 110 from it. And that also gives me 250. So again, you will get the right answer whichever way you go. Some of you might go this way, some of you might see the relationship right away and see that I just subtract out the 110 from the 360 all the way around. Okay, but that's central angles. Next we had inscribed angles, and for inscribed angles, the angle is on the edge of the circle, and the angle is half of the arc. So if this is my intercepted arc of 60, the angle down here is 30. So if I'm looking at a problem like this, I'm looking for arc SR. Okay? Now I do not know in this problem that RS is congruent to QS. It does not give me that information. However, I can go ahead and I can write an expression for the remaining arc of this circle because I have a central angle expression, or excuse me, an inscribed angle expression. So I know if I double that, I will get the rest of my arc, which is from R to Q all the way around. Okay? So now I know that this plus this plus this equal 360. So I'm going to set up my equation. 2 times 7x minus 1 plus 7x minus 7 plus 6x plus 11 equals 360. You're going to combine like terms, so you'll get 14x minus 2, and if you want to just write the rest of it out or start combining like terms, you can do that. And 4x plus 7x is 21x, plus 6x is 27x. Negative 2 minus 7 is negative 9, plus 11 is positive 2. Subtract 2 from both sides. 27x equals 358. Alright, I just realized that I didn't get my 11 up here. Sorry about that. Okay, so when I distribute, it'll be minus 22. And so that'll be minus 22 plus 7x. And that'll make my subtraction down here a little bit different. So let's change this. Okay. So I'll have negative 22 minus 7 is negative 29. Negative 29 plus 11 is negative 18. And now I'm going to add 18 to both sides. And I get 378. And then 378 divided by 27 is 14. And then I can plug that in to find the measure of arc SR. So I'm going to plug that 14 back in here to find that measure. Okay, down here we also did number 3 in class today. So we know that if this chord is congruent to this chord, then the arcs are congruent as well. So I'm going to take 2x plus 5 and 2x plus 5, and I'm going to set up my expression 2x plus 5, and all of those should equal 360. Okay, so arc plus arc plus arc, all of these arcs added together equal a total of 360. Okay, combine like terms and solve. You get 5x plus 30 equals 360. Subtract 30. 5x equals 330. Divide by 5, and x equals 66. Okay, now that's what x equals. If I want to find the measure of ABC, then I have to go back to my figure, and if I look at this, I notice that they want me to actually determine what that inscribed angle is. So if I want the inscribed angle ABC, then I'm going to have to find this arc first. So I'm going to plug 66 in here, and I get that this arc is 86 degrees. So if the arc is 86, the inscribed angle is half of that, which is 43 degrees. Okay, I'm actually going to stop this video here, and I'm going to do a video on the sum and difference, because I think I'm running into 15 minutes here. So look for my next video. The next video will be very short, but I'm going to stop this one here.